Okay, this is the first problem. Obtain the truth table and identify the gate. So this is a neural network which is given to us and we have to identify which gate it is. So the weights, the threshold, everything is given, and as you can see there are 4 neurons. First neuron, second neuron, third and fourth neuron. So we shall name the output of the neuron. The output which, these are the weights. This 1, 1, 1 is a weight, but the output coming from this neuron, we name it as O1 dash, O2 dash and O3 dash. And the final output is already written as O. So depending upon the input and the weights, we shall calculate the net for each of these neurons. So the net, this will be the net 1, net 2 and net 3. And this for the out neuron we name it as net. So we need to calculate. Now to the first neuron we have only one input, and hence for the first neuron I can write the truth table in the form of x1 and net 1 and O1 dash. So input can be either 0 or 1. So when the input is 0, what is the net value? Net value is nothing but x1 into minus 1, that is net 1 is nothing but minus x1. Similarly, net 2 will be minus x2 and net 3 will be minus x3. So I write here values of net 1 is equal to minus x1, net 2 is equal to minus x2, net 3 is equal to minus x3. So I hope you know how we got this. We multiply minus 1 into x3, we get this net 3, and so on and so forth. Similarly, we can write the equation for the net of the final neuron. What will be the net? If at all you see here, the output O1 is coming here and the weight is 1. Similarly, output O2 dash is coming here with weight 1 and O3 dash is coming here with weight 1, and therefore I can write the equation of net as O1 dash plus O2 dash plus O3 dash. So we have written the equations of all the net for the neural network. So now we have to draw the truth table. We have to complete the truth table, but individually we shall draw the truth table for each neuron first, and then we shall combine the truth. So for the first neuron, I have drawn the truth table here, and input is x1. There is only one input here, and according to that we have calculated what is net also. So net 1 is nothing but net 1 is nothing but minus x1, so it will be 0, and here it will be minus 1. Now we have to look at the output. Now what is the output? Output O1 dash. Now for it is the macular-Pitts neuron, and for macular-Pitts neuron model, this is what is the equation. So the output O1 will be 1 if at all net is greater than or equal to threshold. This is net, and if at all net is less than threshold, then the output is 0. So in this case the threshold is 0. So 0 is equal to the threshold, so the answer O1 dash is 1, and minus 1 is less than the threshold, so the answer is 0. The same thing can be done for the second neuron and the third neuron, and since both of their equations are almost similar, net 2 is minus x2 and net3 is minus x3. So we complete the truth table in the similar fashion, net, and we get this. If at all you closely have a look at this, the input x1 is 0. When the input x1 is 0, the output is 1, and when the input is 1, the output is 0. So this holds true for all the gates. So this is a NOT gate, that is this neuron acts as NOT gate. Similarly, this neuron also acts as a NOT gate, and this neuron also acts as a NOT gate. Now we have to find the truth table for the final neuron. And how it will be done is that by taking all the inputs x1, x2, x3. Now we have got x1, x2, x3, 3 inputs. So we will be making use of 3 inputs. So we have here a 3 input truth table where the inputs are x1, x2 and x3. So when we have 3 inputs, we have the combination of 3 bits. So we have 0, 0, 0, 0, 1, 1, 0, 1, 0 up till 1, 1, 1. So according to these values of x1, x2 and x3, we have to calculate the values of net. Now as you know that net1 is minus x1, net2 is minus x2 and net3 is minus x3. So we calculate what is net. So obviously when it is 0, 0, 0 it will be 0. And whenever it is 1, it will become minus 1. So we have calculated the individual net values. So according to that, we have to calculate O1 dash, O2 dash and O3 dash. Now how will we be calculating O1 dash, O2 dash, O3 dash is to check whether the net value is greater than or equal to the threshold. So in this case it is 0 and the threshold t is equal to 0. So if this 0 is greater than or equal to the threshold, then the answer has to be a 1. So in this case it is a 1. So whenever it is a 0, the output O1 dash, O2 dash and O3 dash will be 1, 1, 1. And whenever it is a minus 1, minus 1 is less than the threshold t, therefore the answer will be 0. So I can complete this table also. Now after completing this table, what we have to do is that we have found out what is O1 dash, what is O2 dash and what is O3 dash. That is O1 dash here, O2 dash and O3 dash. So we have found out O1 dash, O2 dash and O3 dash. Now this next step is to calculate net, and the equation for net we already know. What is the equation for net? The equation for net is O1 dash plus O2 dash plus O3 dash. So I will be calculating net from this particular table. So for the first case it is 3, 2, 2, 1, 2, 1, 1, 0. So we have calculated net. Now we have to calculate O, we have to look at this particular threshold, and here the threshold is equal to 1. So if at all the input is equal to or greater than 1, only then the output O will be high. So in this case it is greater than or equal to 1. All these cases it is greater than, only in this case it is less than 1. So the output will be 1, 1, 1, 1. All will be 1s except for the last case it will be 0. So if at all you look at this particular table, it corresponds to which gate? When only all the 3 inputs are 1, 1, 1, the corresponding output is 0. So this represents nothing but a 3 input NAND gate. So we have finished this problem. We have to obtain the truth table. This is the truth table and then identify the gate. So at the end you have to write that this is a 3 input NAND gate. So this is a 3 input NAND gate. Now this is the second problem, and this is a much simple problem. So again we are given 3 inputs, x1, x2 and x3, and there is one neuron, there are only 2 neurons. So we calculate this is net 1 and this is net, and for this particular neuron the output we shall name it as O1 dash. So net 1 corresponds to O1 dash, net corresponds to output O. So again we have to draw the truth table. So how will be the truth table? We shall be having x1, x2 and x3 because it is a 3 input gate. After that we shall be calculating net 1 and then we shall be calculating O1 dash. So we will be calculating net 1 and then we will be calculating O1 dash. So before that we have to find out what is the equation for net 1. The equation for net 1 will be given as, the equation for net 1 is given as x1 into the weight is 1, so it will be x1 plus x2 into the weight, that is x2, plus x3 into the weight, that is x3. So this is the equation for net 1. So we go back to the truth table and complete the truth table 0, 0, 0, 0, 0, 1 and so on. Now based upon the completed truth table, we have to calculate what is net 1 and O1 dash. So as we already know, net 1 is x1 plus x2 plus x3. It is very easy. It is 0, 1, 1, 2, 1, 2, 2, the last is 3. And then we have to calculate O1 dash. To calculate O1 dash, we have to look at the threshold, and the threshold is equal to 1. So whichever inputs are greater than or equal to 1, those will be, the neuron will fire for them, otherwise the neuron will not fire. So what we have to do is that we have to, in this case whatever I have tick mark for them, it is going to cross the threshold because threshold t is equal to 1. So if this is greater than or equal to t, so for all these I will have the output 1, and for only this input 0, 0, 0, the output O1 dash will be 0. So if at all you see only this part, that is here, if at all you see this particular part, then we can say that it is an OR gate. This is an OR gate. And there is some additional part to it. We shall analyze that particular part. But only if this particular part we consider, then looking at the truth table, we can say that it is a 3 input OR gate. Next we have to calculate the other part. Now this is net 1, this is O1 dash, this is net. So what we have to do is that we have to find the equation for net. Now what is the equation for net? Now this O1 dash is getting multiplied with -1 and it is going to this neuron. So the net 1 value is nothing but minus of O1 dash. So we will be calculating net, which is nothing but minus of O1 dash. So O1 dash, you just put a minus sign, so it will be, all the ones will get converted to -1. After calculating net, we have to calculate the output O, and O will be equal to 1 if at all net is less than, sorry, if net is greater than or equal, O is equal to 1 when net is greater than or equal to the threshold, that is 0, and O will be 0 if net is less than 0. So all these cases net is less than 0, so the output will be 0, and only in this case the output will be 1. So we can indicate it as this way. So if at all you look at this truth table, only when the input is 0, 0, 0, that is this particular condition, the output is high. So only when none of the inputs are high, the output is high, and this represents NOR gate. So this is nothing but a 3-input NOR gate. So this part from here to here, it acts as an OR gate, and this part acts as a NOT gate. So basically the resultant is a NOR gate. So if at all you want to write the equation of this is a two-staged output. This is one, this is the second one. So I can write the equation of this particular NOR gate as OK plus 2 is equal to x1 k bar, x2 k bar, and x3 k bar. Why I have written it in this particular way, why it is OK plus 2? It is OK plus 2 because the output is obtained after 2 neurons or 2 stages of neuron. This is the first stage of neuron, this is the second stage of neuron. If I told you to the previous problem also there were 2 stages, so in that case also you can write the output in this particular way. This is the equation for the NOR gate. After this we have this particular problem which is given to us. The logic network shown use the McCulloch-Piss neuron model. Find the truth table and the logic functions that are implemented by these networks. So there are 4 networks which are given: A, B, C, D. Each of them are different. So you have to find out the output. Each of them are having 3 inputs. So after we'll have to find out the outputs as we have solved the previous 2 problems. So I expect you all to solve this particular problems and then send me the answers of them. So I'll have to find out the truth table, and then you have to find out the equation OK plus 1 is equal to what. So in this case, since there is only one neuron, you will be getting OK plus 1. In these cases, you will be getting the equation as OK plus 2. In this case also, you will be getting as OK plus 2. Here you will be getting it as OK plus 1. So you need to get the equations for each of these functions. So if at all you have any doubts, you have to ask me. Is that clear? Okay, thank you.